let us try to solve problems on mean and variance. Let us solve the first problem. Monthly demand for radios is given in the form of a table. Demand and probability is given. Demand varies from 1 to 6 and probability varies from 0.1 to 0.1. Determine the expected demand for radios. Also find the variance. If the cost in rupees of producing n radios is given by P equal to 1000 plus 200 into n. Let us first find out the mean value. Expectation of x is given by summation of x, probability of x equal to x. That is 1 into 0.1 plus 2 into 0.15 plus 3 into 0.2 plus 4 into 0.25 plus 5 into 0.2 plus 6 into 0.1. So therefore you get the x bar and mu x as 3.6. Expectation of x square is given by summation x square, probability of x equal to x. So 1 square into 0.1 plus 2 square into 0.15 plus 3 square into 0.2 plus 4 square into 0.25 plus 5 square into 0.2 plus 6 square into 0.1. That will give us 15.1. Once we know the expectation of x and expectation of x square, we can find the variance of x, that is ex square minus ex the whole square. Ex square is 15.1, ex whole square is 3.6 whole square. That gives you 2.14, that is the standard deviation whole square. Standard deviation is root of 2.14, that is 1.463. Now we can find the cost of radio, that is given by the formula 1000 plus 200 into the mean value. The mean value computed is 3.6. So you get 1720 rupees. We'll try to solve the second problem. You need to calculate the mean and variance for a random variable x defined as the number of tails in 4 tosses of a coin. Also draw the probability distribution. In the 4 tosses, in all the 4 tosses, if you get heads up, then it is H. Only one outcome is present. T. That means in all 4 tosses, we get the tails up. Then we have 3 tails up. We have 4 evens. Then we have 3 heads up. We have 4 possible outcomes. Then we have 2 heads and 2 tails. We have got 6 possible outcomes. Using this, we can form the table. X values for 0 tails, 1 tail up, 2 tails up, 3 tails up, 4 tails up, and probability can be computed using this. So you can see that when x equal to 0, all 4 tosses we get the heads up. That is only one possible outcome. Total number of outcome is 16. So therefore 1 by 16 is equal to 0.0625. Then we have one tail being tossed up. One tail is shown among the 4 tosses. So we have 4 evens, 4 by 16, that is 0.25. Then we have 2 tails shown. So we have totally 6 evens. So 6 divided by 16, that is 0.375. Then we have 3 tails up. We have 4 evens. So 4 by 16, that is 0.25. Then all tails being shown up. That is 1 event. So 1 by 16, that is 0.0625. Using the label, let us compute the mean x bar. Expectation of x, mu x, is given by summation x into probability of x equal to x. Therefore, it is 0 into 1 by 16 plus 1 into 1 by 4 plus 2 into 3 by 8 plus 3 into 1 by 4 plus 4 into 1 by 16, that gives you 2. X square bar, that is expectation of x square, is given by summation of x square, probability of x equal to x, that is 0 into 1 by 16 plus 1 square into 1 by 4 plus 2 square into 3 by 8 plus 2 square into 1 by 4 plus 4 square into 1 by 16, that gives you 5. Once we know Ex square and Ex, we can compute the variance. Variance of x is given by ex square minus ex whole square. That is, ex square is 5, ex is given as 2. So 5 minus 2 square, that is equal to 1. That gives you standard deviation whole square. So standard deviation sigma x is root of 1. That gives you 1. Let us try to solve the third problem. Data is given in the form of a table. K value, yk value or probability of yk are given, and k value varies from 1 to 5. Yk value varies from 2.1 to 6.9. Probability of yk varies from 0.2 to 0.26. We need to compute the mean and the variance of y. Given w equal to y square plus 1, we need to compute the mean and the variance of w. Let us try to find the mean of y. Mu y is given by E of y, that is 2.1 into 0.2 plus 3.2 into 0.21 plus 4.8 into 0.19 plus 5.4 into 0.14 plus 6.9 into 0.26. It gives you the answer 4.554. Then expectation of y square is given by summation of y square. Probability of y equal to y is 2.1 whole square into 0.2, 3.2 whole square into 0.21, 4.8 whole square into 0.19, 5.4 whole square into 0.14, 6.9 whole square into 0.26. That gives you 23.874. Knowing the value of E of y square and E of y, we can compute the variance of y. Variance of y is given by Ey square minus Ey the whole square. That is 23.874 minus 4.554 whole square. That gives you 3.135. That is equal to standard deviation whole square. So standard deviation can be computed by taking the square root of 3.135. Next, we have been given w equal to y square plus 1. E of w is equal to E of y square plus 1. That can be written as E of y square plus E of 1. E of y square is 23.874. E of 1 is 1. So we get this as 24.874. So if you want E of w square, then it is E of y square plus 1 the whole square. That gives you E of y to the power 4 plus 2y square plus 1. That gives you Ey to the power 4 plus 2Ey to the power y square plus E of 1, that is equal to 1. So when you substitute the value, we get the answer as 884.298. Then we have to compute E of y to the power 4, because that needs to be substituted here. So E of y to the power 4 is given by y to the power 4, probability of y equal to y. So that gives you, this is 2.1 to the power 4, that is 19.45 into 0.2, 3.82 to the power 4, that is 104.86 into 0.21, 4.8 to the power 4, that is 530.84 into 0.19, 5.4 to the power 4, that is 860.31 into 0.14, 6.9 to the power 4, that is 2661.66.71 multiplied by 0.26. So you get 835.16. That is being substituted here to compute the e to the power E y square, w square. So variance of w is given by E w square minus E w whole square, that is 884.298 minus 24.874 whole square. So that will give you 265.58. That is the standard deviation whole square. So the standard deviation is root of 265.58. We'll try the problem on mixed random variable whose PDF is given here. The f of x equal to c of delta x minus x plus 0.13 for all values of x between 0 to 4, 0 otherwise. We need to find the mean and the variance of x. By integrating fx of x, we get the CDF and its value should be equal to 1 for all values of x which is greater than 3. So we have here integration of fx of x dx, that is integration of 3 delta of x minus 3 dx plus integral of 0 to 4.13 dx equal to 1. Integration of a step function, integration of an impulse function is pure step function. Integration of this is 0.13x. Its value varies from 0 to 4. By substituting for all values of x greater than or equal to 3, this value becomes 1. So it is to C now. C plus 0.13 into 4, that is 0.52, that is equal to 1, which means the C value is equal to 0.48. So let us substitute C value here 0.48. So then we try to get the mean value. E of x is equal to x in integral of x into fx of x dx, and here integral of 0.48 into x delta of x minus 3 dx, integral of 0.13x here. Then we do the integration and substitute the value. We get this as 2.48. Similar way, we can find out the x square mean. Only difference is instead of x, we will be having x square. So we will integrate 0.48 x square delta x minus 2 dx plus integral of 0.13 x square dx. When we integrate and substitute the corresponding values, we get the values as 7.093. Once we know E of x square and E of x, we can compute the variance of x. It is E of x square minus E of x whole square. That gives you 7.093 minus 2.48 whole square. That is 0.9428, and that is equal to sigma x square. That is standard deviation whole square. So if you want the standard deviation, take the root of this 0.19428. Thank you. In the next video, we solve some problems on distribution.